yeah, so let's get straight into this thing. If anyone has any questions or thoughts or comments or like suggestions for directions we can take this in, then please do let me know in the chat. Otherwise, I've been thinking, as I was having my breakfast this morning, I was having a little think about how we might approach this. And I think the key is, you can see that this thing is made of like nodes, right? We have these kind of corners and these like form districts, and then buildings are kind of filled in between those. Roads kind of end up placed like along these lines of this. You'd call it a graph, I suppose would be the technical term for this kind of arrangement of all these points. So I'm going to do something kind of similar to generate this. So I think what I want to do first of all is have the user be able to like draw some of these regions or polygons. So which are basically like a set of points or polygons. And then think about kind of placing roads and buildings inside these. And we'll think a bit more closely about how to do that later. I've got an idea, but we'll see where we get to there. That's supposed to be a plus. Something I'm really not sure if we'll have time to do, but which I'd kind of like, is to sort of totally be able to generate a city layout randomly from scratch, which would basically mean randomly generating these regions, and then, you know, those will get filled in as normal. So kind of randomly placed regions. I also have an idea of how we could do this, but just in terms of time, I don't know if we'll get it done within one stream. So step one, right, is to start drawing these regions, and I think the way to do that is we'll have our screen something like this, and I'll just have the user like click some points, you know, like click here and here, maybe here, and maybe they click back here, and then it goes, okay, I'll make that a polygon. Then maybe they want to draw like a neighboring area, so maybe they click here again, and it will like snap to that point for them. Then they click here, then like here, then back here, and it will kind of connect this thing up for them. And then once we've got these, we can think about how to fill in some roads and buildings and stuff inside those. So in the last coding stream we used Unity, but I think I'm going to be back to using processing this time. Tweak my size there. There we go. So I think what we're going to need is probably going to import some utility stuff. It's going to be useful. So again, in processing, it has a setup function, which is called once at the start, and it has a draw function, which is called for every frame. So if you've seen the stream before, this will be super old news to you, but that's how processing works. So if we're going to be laying down points, I mean, a point is just a set of coordinates, so we kind of need to have a list of these, I think. So I'm going to create just a global list of, how do I want to do this? So I could do this using processing vector class. Yeah, that'll work for me. Okay, so I'm going to make this an empty array list. And then the simplest thing to do here is just say, when the user presses the mouse, I'm just going to add a point to that list at whatever coordinates they happen to click. So Mousepress is another one of these built-in processing functions. If you define this, then it will call this whenever the mouse is pressed. I think I will, yeah, do something as simple as, no, ignore that typo. So we're going to add a new entry into here with the mouse X and the mouse Y. Cool. And then when I draw, it probably makes sense for me to first clear the screen to like a black colored background. This, by the way, is shorthand for just saying like RGB 000, which is black. If it's like a gray tone, well, all these numbers would be the same. You can just put one number in. It's a little convenience thing that processing does for you. Yeah, so then I'd kind of like to draw our points. Ultimately, we may not do this in the end. It may end up being like some debugging stuff. Like by default, it may just look like this does, but then when the debug mode is on, we'll probably draw these points and lines to help us with kind of debugging stuff. So I think I'll just say loop over all of these, and then I'll just draw a little circle at that position with a size of, I don't know, let's say 10 by 10. So this circle will have no outline and it will have a red fill color. Okay, I should probably also set a window size. Like we can make this pretty big, so kind of guessing here. So here we're telling it the width and height of the window, and we're telling it which like rendering mode to use. Maybe a spoiler, I'm thinking we could like make this 3D as well. I feel like that's actually not much harder than doing it in 2D, so we may look into that at some point. I think it didn't like that syntax. So in Java you can just do this, right? Which is saying, hey, I want a list of p vectors, and I'm going to initialize it to an array list, and it can just infer that you mean this should be the same, right? It's like just copy and paste this into here. So in modern Java you can just do that, but I guess the version that processing is built on, it's not like that. I have to explicitly say, it won't like infer that for me. Okay, so now we have our blank canvas. I think this is a reasonable size as well. And if I click, I'm adding points. Cool. That's pretty simple. The next thing I think is to go from just adding points to adding polygons. So processing is built in Java. This basically is Java. It's weird. It's kind of like a library for Java, but it also has its own like editor and IDE. Like if you're used to Java, what we're actually doing is kind of writing a class here, but it doesn't make you write all of the like surrounding stuff. You know, in Java I'd need this, I'd need like a main method and like an entry point to the program. It just kind of abstracts that away from you, but ultimately this literally is just Java. But all of like the rendering code specific stuff is processing. But yeah, but this is legit like Java code. I think you can just import processing as a library from a regular Java program and use these same bits of functionality, but yeah. It's in a weird place between like a language and a framework and a library. So we're placing points here. I think we need to start thinking about adding these points into a polygon as well. So what is a polygon? A polygon is a list of points, basically. This is where this would be really handy, because I wouldn't have to duplicate all of this stuff here. Once you start nesting these things like this, it gets kind of weird. So screen points is just going to contain, you know, like x 1 2 3, y 27, you know, a list of coordinates like this. And then our list of polygons is going to contain a list where each polygon itself is like a set of, like, you know, x, y points. And that was a terrible way to try and illustrate that. And I think what I also want to do is not like duplicate. So I suppose the question is, why do I have a separate array of points out here when I'm already storing them inside the polygons? The reason is that I want to be able to like ultimately like pick up and drag this point and have it affect like both of these things. So rather than them each having a copy of this coordinate, I want them to literally have a reference to the same like point object in memory, so that if I change it, you know, all of these neighboring things will get changed kind of in line with that. That's kind of why I'm anticipating doing this. So it feels like the way we want to do this. So we're drawing a polygon. I'm going to draw a point, you know, and that's going to get added to... It's going to get added to this list of points which we're building up. Was it screen points? Then we had polygons. It's not yet a polygon, so we're not going to add it to this list just yet. But I feel like we need like a current polygon or like an in-progress polygon so that we can build up all of the points for that polygon. And then when the polygon's finished, it gets like loaded into this array for us. Kind of like this lasso tool, right? Like I can do this kind of thing, and then if I press enter, it like finishes it off. That's kind of what we want. So I want to track probably the polygon which we're currently like placing points down for or drawing now. Okay. So I think what I want to do is when I press the mouse, I'm going to grab a reference to this point which we've clicked. I'm going to add it to the list of screen points. Yeah, I was debating whether we should do this now or wait till the polygon's like completely finished before we add those in, but depends if we need like an undo or cancel functionality, but I think this should work. So we're adding it to the current polygon. And then I think what I want to do is like, if it's a right click, then I want to say, okay, that's now the polygon done. So I can do something like, yeah, let's look up how we get the right mouse button in processing. Mouse pressed. Mouse button variable can be used to determine which button is pressed. Mouse button equals right. Okay. It looks like they have a constant defined which will indicate that it's the right button. So whether it's left or right, we're kind of adding a point to the list. But if it's the right, then that's also going to like end the current polygon. And I'm going to say polygons at the current polygon. Sorry, in progress polygon. And then I'm going to kind of empty out this in progress polygon, ready for the next one which gets added. So I'm going to kind of create a new list for it. Okay. So here we're drawing the points. I feel like I also want to draw the polygons now, and probably also draw the in progress polygon. So I may even make this a utility function because I figure I'm going to need to do something similar for in progress polygon, but like maybe a different color or something. So just going to make a little utility function which will actually do the drawing. So I can just say like this, and then do like don't want to fill these in for now. Let's say they're red. Let's maybe draw the current one in green. Okay. So, how do we draw a polygon? Actually, I think processing has functionality which will do this for us, but I feel like I'm not going to use it. So, okay, so there's partly because I kind of want to explain how you actually do this, and secondly because I feel like we may want to do some more custom drawing where each side of the polygon looks different. Like maybe we want to be able to tweak like how wide the road is along a certain part, so you know we can show some extra information there. And also partly because I think the logic of like filling this in with buildings is going to involve a lot of thinking about these line segments kind of individually. So if you just lean on processing and say, hey, here's a list of points to draw a polygon, then we're kind of skipping over what that actually involves. And what that actually involves is we'd have a set of points. So the smallest polygon has 3 points, obviously. So maybe this is point 0, this is point 1, and this is point 2. So we essentially want to draw lines between like 0 and 1, between 1 and 2, and then from 2 to 0, right? So, wow, my tablet really doesn't like me drawing lines. So that's 0 to 1, 1 to 2, and 2 to 0. So it looks like we're going to loop through every index in this array and then sort of connect it to the next one. And the only special case is when we're at the last element, we can connect it back to element 0 here. So what we're going to want is something like, rather than a for each, I'm going to do a for with an index thing like this. So this will go through every index. The start point is just going to be look up that. We need to think about the next index, right? So you could think it's just I plus 1, but then we need to handle this case where it wraps around to 0. So I'm going to use modulus for that. So modulus, if you're not familiar, it causes this to wrap around. So if you have like 1 modulus 3 equals 1, 2 modulus 3 equals 2, but 3 modulus 3 equals 0. Yeah, then 4 modulus 3 equals 1. It sort of creates this cycling thing where it never gets up to this second number. It just loops back around to 0 at that point, which is exactly what we want to happen here. I could have done something with just like if I is equal to the last element, then next index is 0, but this is the way that I think about this these days with modulus. Which implies the endpoint is just the next index, and then all we want to do is use processing to draw a line from start point.x start point. So I always think it's kind of a missed opportunity that processing doesn't just allow me to like pass in a vector. This is what I really want to do, right? But I don't believe there's such a thing. Yeah, you kind of need to pull out the components individually. Okay, so that's how polygons are drawn. Hopefully this will do what we need. So I can click, I can click, I can click, and now if I right click, that will place the final point. So cool. There's one polygon. Boom. So we can make our city districts like this. I think that's what we want. What I'd really like to be able to do as well, though, is say I click again here. What I may not have been able to see that, but it actually like started drawing another point. What I really want it to do is like if I'm close enough to an existing point, it's just going to like snap to it. So I think one way to do this is, again, I'm going to make a little utility function, get which is going to do something like, so it's going to loop over all of these points. P. So what's going to be convenient here is to create a vector for the mouse position, and then I can just say something like v dot dist. What I kind of want is you know what, I was going to do like a squared distance because it's slightly more efficient, but it's totally unnecessary here. Then I'm going to say if that distance is less than the distance, or if the closest is null so far, okay, so this is a very super common pattern for finding like the smallest thing or the closest thing. So I'm going to go over every point, I'm going to calculate the distance from the mouse point to this particular point, and then I'm kind of keeping a running total of what's the closest point I've found so far. So if closest point is null, then it means probably this is the first time through the loop, and this is the first point we're considering, so straight away it's the closest so far. Otherwise we want to check that the distance is less than the previous most close distance, and then update this. And then I want to say something like, we probably want a threshold here, right? Like a snap distance, let's call it 10 for now. I'm going to say if the closest distance is within the snap distance, then I'm going to return that point. Otherwise I'm going to return null. So we'll return the closest point but only if it's within this sort of minimum threshold. I think what I also want to do is something like to highlight that so we know when we're going to snap. And then I think I'm going to say if this is that snap 2 point, then we're going to do it in one color. Otherwise, I'm going to do it in this color. So what they should hopefully do is that if I place down points, we can see when I'm close enough, it now starts to snap. So I can create something here, and now hopefully I can create a polygon which is like exactly, okay, it's not actually doing the snapping when I create the shape, but so what I kind of want to do here is first we're going to try and snap to a point, and then only if it failed to snap because we're not close enough, then I'm going to create a totally new point with the exact mouse position. We only need to add it to the list if it's not already there. Cool, so this will say first we're going to check if we're snapped to anything. If we are, then that will be the clicked point, otherwise it's a new point. We're going to create that vector based on the mouse position, we're going to add it to our list of points. So now there's a slight issue in that it will let me like connect back, but we'll call that user error. So right now if I press right click, it's going to add a new point and finish the polygon. I think what I actually want it to do is if I press right click, I just want it to like lock in what's already there rather than do what's going to happen now, which is that. So that's a kind of little usability tweak I may make. So now that we can snap, that'll get snapped exactly there. Then I can build my more complex section, and now these points are kind of unified. Cool. So let me change this to do that, and then we're done. Okay, should do what I want. I also want to be able to drag these points, so I think the way I'm going to do that is so, well, obviously I want to like click and drag, but in terms of like drawing points, when should that happen? I could do something like if the shift key is held, or if I'm not yet kind of drawing a polygon. I think maybe I will do it based on the shift key. Actually, no, that's kind of awkward to do. I think maybe so if the current polygon has no points yet, then I'm going to actually start dragging this point. Yeah, this branch is kind of getting a little bit chunky, but you know, this drawing stuff is really just to get us to the stage where if we can actually think about the procedural generation. So even though this is not the cleanest way to express this, I think it will do the job for us. it's starting a drag, we don't want to actually add it to the polygon. Is it mouse move or mouse moved? Let's take a look. Mouse moved. Okay. Now when the mouse is moved, I say if we're dragging something, then I'm just gonna update its position. Okay. The mouse is released, then we're no longer dragging anything. Okay, so hopefully this does what we're expecting. So I can click to place a point. I can right click to lock that in. I should now be able to click. Oh, no, didn't like that. What's happening here? Fire up the debugger quickly. What I want to do is to draw something, and then I'm going to add. How do I add a breakpoint here? Didn't seem to like that. Can I not toggle breakpoints while it's running? That's kind of weird. Variables up here. That's weird. Why can't I now add and remove breakpoint? I suppose because it's in a broken state, in a breakpointed state. Probably doing something really dumb here. Oh, okay. I think I get it. Mouse moved is not called. If you're dragging, which is kind of counterintuitive, I'm pretty sure that's it. A little processing quirk there. Okay, cool. Now I can add stuff in, and we can start. Cool. So I can start to build. I can imagine building like city districts and stuff out of this. It'd be nice to have other functionality like splitting these up, or selecting multiple points, but that's stuff we could always add later on. I think this will let us test out a bit of city generation, like the visual algorithm side of this in any case. Cool, so now we have these things, we can start thinking about our real objective, which is rendering some cool stuff like this. So, if anyone's just dropped in or wants a kind of recap or has any suggestions even for how to go about this, then please speak up in the chat. Otherwise, I'm going to kind of explain. We've kind of done this part, right? We've placed these points, we've made these polygons, we can move them around. It's not the most user-friendly thing, but it's something we can like build a bit of a city with. Now I want to think about how to actually draw the content inside this stuff. My idea is something like this. So we have a polygon made of points. Draw this kind of big. And this is going to have neighbors also. And we want to start drawing our city on top of this. I have a kind of idea for how to do this. So the first one is I want to be able to, how should I say it? I want to be able to put roads in between these. So I think the first step is that we need to kind of step back a bit from the edges and draw, like leave some space for the road. And maybe we should be able to tweak like how wide this is, and maybe this varies in different parts of the city and so on. So first thing is like leave a gap for the road. There are cases where this may get weirder, right? Like maybe there's another block here and we actually want them to like connect and have no road, but this should be a road. So maybe for each line we need to specify the thickness of the road, but it could get kind of messy, like how this junction works if this one has no road but this one does. But anyway, we'll just consider the case now where each district has like a road around it because it's just way simpler. So yeah, so this is going to be our road space here. Kind of all around. And then what I kind of want to do is start drawing a kind of layer of buildings in a sort of similar way. So what I kind of want to do is to... So the road is like stepped back a certain amount. And the way I think I want to do this is to inset it from the corners kind of along like these lines, if that makes sense. The lines which kind of go through the corners. Because I feel like that naturally aligns with like how we would visually expect this stuff to work. So the way we're calculating this is we're kind of taking like, imagining like this direction and like this direction. And if you like split the difference between those, you end up with this thing, which we can then like reverse to point inwards, if that makes sense. So we can sort of average out these two lines and then step in along that, and that's going to determine like the point where our this corner of our like road section ends. So we're going to do something like that, and then which will ultimately give us another kind of block within here. So it's going to be something like this. Again, this may not super well account for like really narrow, like triangular shaped sections or like really wedge shaped things. You know, you can imagine making this more narrow, and this thing would kind of like cross over itself in a weird way, like this, if there's no like middle section. But as a first pass, this is kind of how I want to think about this. And then what I'd like to do is to kind of place buildings down in here. So simplest way is just to like divide it up into regular kind of blocks. But you could get more fancy, right? Like you could have a building which is like this shape, kind of buildings with curves in them, or buildings with like little notches cut out of them. And by assembling things like that, I feel like we will come somewhere close to, yeah, if you look at this section in particular, this is kind of what I'm imagining. It's doing some fancier stuff with like how these fill in the middle, but it's more like, yeah, like this side or like this side or this side is kind of what I'm thinking about trying to get going as a first pass here. There are some corner cases, literally corner cases, where yeah, these sections need to be handled differently somehow. Maybe we need special kinds of buildings which can fit into the corners, or maybe not. And I'm also anticipating, by the way, that these buildings will get kind of warped as necessary to fit the geometry. So what would be cool is, say for this building here, if we could define like a kind of prototype for this building, like a perfect sort of ideal for this. Maybe where it's in a coordinate where this is like 0 to 1. This is like 0 to 1. And then that just kind of gets mapped and scaled and translated to fit into this gap. Yeah, then we can have a library of these little blocks. Maybe some of them are like not just one wide, maybe we have like some like double wide buildings or something like that, or triple wide, or maybe they can be arbitrarily wide. But we kind of pick from a pool of these and kind of fill out this space. There's another potential issue, which is that let's say we start adding these buildings in, and if they're a certain size, then we end up with like some blank space. So what do we do here, right? And I think there's a couple of ways around it. So we could kind of try and pack in as much as we can, and then like rescale these to like fill the space. So maybe it ends up like, you know, like slightly scaled to like fill the gap. Or what might even be cooler is if we introduced like little gaps, like alleyways between. So then, you know, this one would end up filling up the whole space. I think, yeah, when I was thinking about this morning, I was thinking about kind of stretching them out to just to, like fill that gap, but I kind of like this alleyway approach even more. It feels like we'll end up with a more natural city layout that way. I'm sure some of these things have like gaps and alleyways. Maybe not really. We make this super big. It looks like they're not doing that, but we can, you know, we can make something like that happen. So, how the hell do we do this? I think first pass, I'm just going to do these with like squares or blocks. In fact, the first pass is just to draw these roads, right? So let's have a think about that. This is kind of our like debug drawing here, which we'll leave on for now. So that's drawn those polygons. So I feel like what we need is... Okay, so in order to draw this road section, we need these 4 corner points of this like inner blue section. To figure those out, we need to do this deal here, right, where we take these 2 lines and we kind of find an average and then like step in along that based on the thickness of the roads. So I think what I'll do is... It might be nice to even draw those lines. Okay, I feel like I need some more utility stuff here. I'm going to make a geometry utility class here. And then I'm going to put our little helper functions in here. So what would we call this? It's probably like a bisector, or kind of like a vertex normal. Oh, yeah, I'll call it like the corner normal. I'm sure there's a better term for that, but so it kind of needs to have, kind of need to give it the polygon and like the index of the corner, something like that. Okay, so what I need to calculate this is I kind of need like this line and this line. Basically what this is, it's like the average of these 2 lines and then inverted to like flip it back over. So that's the previous thing. Previous point is going to be, I'm going to use the same little modulus trick, so it's corner index -1, but we need that to wrap back around to size of the polygon. And then the next point, it's going to be that +1. So now we have, let's kind of draw a diagram for this. So we have our corner, we have our previous point, and our next point. So I'm going to call this like C, next, and previous. So if you're thinking about this direction, it's really just the vector from the previous point to the current point. Which kind of gives us this vector here. But what I'd like to do is, it matters that these are different lengths, right? Or they could be different lengths, so I'm going to normalize these so that they have a length of, they both have a length of exactly 1. So then that will give me a little vector like a length of 1 pointing this way, length of 1 pointing this way. And then when I normalize those, I'll get, sorry, when I average those, I'll get a vector in the middle, and then I can negate it, have 1 pointing that way. Cool. So So I'm going to subtract the corner point from the previous point. Will that work? Did it not like that? Okay. Am I really missing a semicolon? Yeah, so sometimes this editor gets a bit behind on like compiling stuff in the background to check your syntax. So actually just do kind of the average of these, which is the same as saying adding them together. Multiply by 0.5. Okay, so then I just need to return the mid pointing normal, which is multiplied by -1. Okay, I think this will do what we need. So by way of debugging this, I'm just going to kind of draw these normals for us. And this is getting kind of math and geometry heavy, so if anyone has any issues or wants me to like explain anything else, I can certainly do that. So when I draw the polygon, I think I want to look like an anti-normal or something. I don't know what the correct term is. So it's this polygon, and we're at point I. Then I think what I want to do is, so this is just going to have a length of 1, so it's going to be like one little tiny pixel if I draw it. So I'm going to kind of scale it by some amount. But the way we're going to do this is x plus times, I don't know, let's say 20. So kind of drawing this little line here. So it starts on the corner, and then we're going to add this normal. I'm going to scale it up just so it's big enough to see. So it starts at the xy of that point, and it ends at the x plus the x part of the normal. Okay. It's kind of a wee bit ugly. If my text size is too small for anyone, by the way, also give me a shout and I can fix that. I've also got some extra print lines in here I don't want. Where are we? Ah. Go. mean, this may throw an error when there's only one point here. Yeah. Okay, so I think we're getting an issue with the wrapping, so I'm going to hack that in there. Nice, okay, so we're getting these little points, which to me at least appear to be pointing inwards. Let's try some really like sharp angles, and then some really like, wide angles. Okay, it looks like the length of these is not consistent. It's probably because I forgot to normalize something somewhere. Oh, it also kind of implies something else, right? Which is that if it's... Yeah, this is an edge case we're not accounting for. If we have like concave sections, then that normal is actually going to point out. I'm sure there's a really elegant way we can handle that. First of all, I want to make sure that's normalized. Cool. This is okay. This is interesting. How do we account for these? I know. Maybe we can calculate the angle between these two lines, and if it's less than some amount, then it means that we're so something weird happening here. I feel like there's some like super simple geometry property which I should probably remember, which will tell me if this is convex or not, to do with well, I guess if you can may depend if it's clockwise or anti-clockwise. If you assume these are clockwise, then maybe it's something like, I mean, I can just compare this angle to this one, right, to detect this situation. Or I can do something like directly detecting if this normal is like outside or inside the shape somehow. I'll tell you what, okay, let's ignore this for now. If there are any maths geometry gurus in the chat, that they can tell me the little one-line expression that will allow me to distinguish these two cases. Otherwise I will kind of do that later and get more into like the actual rendering stuff. So if I want to draw these, then gen class. Add something here which will draw a region, and a region is, again, just a list of view vectors, just one of these polygons. So, I feel like what I kind of want to do is break this down into line segments, or do something like kind of haven't been doing it in these streams, but it's good practice when you create like an array list. If you know what size it's going to be, like in this case I know it's going to be equal to the size of this thing, you can tell it this in advance and it will kind of pre-size it. I mean, efficiency is not really a concern here, but I feel like that's good practice, and normally I do this. Okay. And add that to a list here. Do something similar here. In fact, I can do this in the same loop. So calculate that corner inset normal. Maybe I don't even need an array for these. Probably don't actually. So where's the vertex of the road? We're going to take this corner, we're going to add our little vector onto it, and then it's going to be here. So I'm just going to add the corner inset normal. Oh, sorry, I'm going to add the corner, add the normal. So we're going to take the vertex, and then we're going to add in we're going to multiply the corner inset normal by probably some constant like road radius. I call it radius because it's kind of going to be this distance here, which is actually like half the road because the neighboring section is also going to contribute to that. So, I don't know, 5. Okay. Don't know about you, whenever I see this error I just keep adding parentheses until the red squiggly goes away. And I also use like color-coded braces, which is something I've considered might be kind of nice. Yeah. Okay, what do we do here? So we've got these road vertices. I may as well just go ahead and draw those now. Actually, just gonna put this in here. Looks like it maybe belongs more in here than anywhere else. Ooh. It doesn't like that. Okay, maybe not. Yeah, there's this weird thing to do with how processing actually creates these kind of implicit Java classes, which everything gets nested inside. Well, let's make a actual class for a region, maybe. Just gonna have you know what, these functions will be global, so I can actually call these anywhere. Generate region from that polygon. Tell it to draw the road vertices for me. Okay. Yeah, unfortunately processing makes using static stuff a little bit more of a pain in the arse than it needs to be. This region is like an actual city region. Cool. So we're seeing something here. It's kind of small, the roads are quite narrow. But you can see that it's drawn a second polygon here, which is like inset from the main one. And probably if I to increase the road radius. Let's see something here. Cool. So we're starting to get our city blocks. So okay, so there's something happening here, which is when the angle is like really acute. It's not keeping like the same distance from here, so maybe there's an ideal point where I think I'm going to stick with this for now. Yeah, that kind of gets funky there. We'll deal with that later as well. For like most sensibly shaped regions, I imagine this will be at least kind of okay. Yeah, like this kind of thing. But when it gets really acute, the road doesn't maintain its width. I mean, if we wanted to do this a bit more rigorously, I guess we could do something like if we had a corner like this, then instead of just like moving a certain distance along here, we could find a point where, so we want to maintain this distance for like the road thickness. We could do the same thing kind of like this, and then actually calculate it in terms of like the intersection of these lines. Yeah, which is based on like offsetting here by like 90 degrees away from here, right? Like it's something more like this. But again, that's an enhancement we can easily make. Put this in geometry actually. So we'd actually do it something like what we do here. Normal. So for now we're doing it like this. We use vertex and point kind of interchangeably here. Yeah, so this is one way of doing it. We can switch this out in the future for maybe this more fancy approach, but for now, I'm cool with this as it is. And then here, I'm going to say, you can now simplify this. Just say, generate inset point, the polygon from the ith thing, and it's going to be the road radius. Cool. That's the road vertices. Or like the inner vertices of the road, I guess. So we want to do something similar for the building vertices. So now we've got this road. We want to draw buildings, so we need yet another kind of thing in here. Just going to form, then our buildings are going to go in this space. So I'm calling these are like corner vertices, these are road vertices, and then these inner ones are building vertices. Maybe not super clear, but will do for now. So now we're going to add a building vertex. Like building thickness. Maybe 20. So we take the road radius and then plus the building thickness here. Because this is still being outset from like the very outer edge. So cool, I don't think we're actually drawing them. Let's draw those as well. Boom, so now we've got two levels of things here. I feel like we could make the buildings considerably thicker than that, probably. Kind of depends on the scale we're thinking about. Yeah, seems nice to me. Create these districts, we're getting roads between them. This is where it gets a little bit funky. If they're not square, or if we have any like, yeah, like acute angles, it doesn't really like. So this can certainly be improved, but for now it will do something reasonably okay for us. So we should expect that distance there is the same as that one there, right? I don't know if visually it kind of doesn't look like that, but I'm sure it is. Bit of an optical illusion. Let's measure this. Here to here. .64 pixels. Here to. Yeah, the same. Just looks a bit weird because of the way this works out. But this will do for now. I think we can start jamming some buildings in here and then think about how we handle some of the other cases. So we kind of have a nice diagram actually now to work with. So to draw these buildings, I kind of essentially want to like divide this thing up into like regular points. And then, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the same number here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not perfect, but you know, these will kind of link up in this kind of fashion. Yeah, I did not draw these in the right position. Hopefully you get the idea, right? We like subdivide the inner line, so it was in 2, an easier example, and then this is in 2 as well. And then we kind of connect these up to form the basic buildings. Cool. Yeah, the more I'm doing this, the more I'm realizing that to handle some of these edge cases, we probably need some different things going on here, right? Like maybe here, what we actually want to do is build buildings like this, as opposed to kind of like in this style. So So maybe what we actually need to do is like restrict the row of buildings to a smaller segment of the line, something like this, and then deal with the corners as a special case. Otherwise we're always going to get like wedge-shaped buildings kind of coming into the corners like that. But I think that's not such a terrible thing for now. So I feel like we need a list of buildings, and each building again can probably just be a list of points. Yeah, this name is not any good now, so if this is like the street, this is like the back end of the buildings, like we'll call this like building back vertices. And the road vertices are kind of like building front vertices. But I think we're okay. Okay, so here we're kind of pre-calculating the road and building lines, and then here we're actually going to generate, populate stuff with buildings. So I think we also want to, yeah, so we also want to iterate over the edges, and we will kind of need the, so I is the kind of, we're sort of iterating line by line here, right? So we're considering like, whereas a line now is kind of this whole like segment. It's got two lines, right? We've got the building back line and we've got the road line. So we're iterating over each of these lines, so we need to know okay. Now, when we're placing these buildings, I also think we'll need to just consider one of these sections for now. So I kind of wanted to subdivide this into a number of sections, but we need to, I guess, pick either the back row to like derive that subdivision, and then have that like projected back out onto this front row, or do it the other way around, right, where we take the front row and then sort of project them back. I feel like maybe it makes more sense to derive everything like from the front row, like the row that's like facing the street, because you kind of want the front face of your buildings to be nice and square, and then if they end up going into like little wedgy things in the back, that's, you know, which they might do here, for example, that's probably less of a problem. We want the like buildings to be similar sized in terms of their front faces, and then if there's any weirdness, we just hide it in the back. So let's consider the length. Equals. So we're going to subtract let's actually put all of these out. P vector Even call this like front. That's more what these really are in the context of making buildings. Okay, so we're going to take the difference between these. So we're going to find the vector between two like front faces, and then we're just going to measure the length of that. And then I feel like we want to convert this into like a standard unit of measurement based on how big buildings are, maybe. Yeah, I feel like that's the way I want to do this. So the building thickness, the building width. Let's have them kind of squarish. Yeah, let's see how this looks. So we're going to work out how many buildings fit here. We probably want to round down. Cool. So I think what may also... So let's say we decide there are going to be like 3 buildings here. And then a little bit of leftover. And we'll figure out what to do with this later on. It would be useful to know, if this is like the start vertex and this is the end, I think it would be useful to know what's like this step between one and the other, and then correspondingly on the back row, what's like this little step between one thing and the other. Yeah. So okay. So the step is going to be... Oh, okay, it's going to be simple. So it's going to be... So we're going to take that front face and scale it by however wide a building is compared to that entire length. Okay. Which is actually the same ratio here, yeah. I was thinking, should I refer to the back face here? But I don't think we should, because then we would have the building sized differently along the back face. They're being scaled kind of in proportion to whatever the front face is. So I believe this is correct. So okay, simplest way to have a building now is... Hey, CJ Steele. So this is, what we're using here is a framework called Processing, which is something built on top of Java. So it's kind of like a Java library for graphics and interactive stuff. It's designed to be like a very fast and easy way to get graphics drawn on screen using Java. Yeah, so it gives you a load of functions like for like drawing lines and vertices and points and doing some basic like graphical OpenGL type stuff. But ultimately, yeah, the language here is... this is just Java basically, except we're using this kind of processing framework. It's a little bit weird in that it has its own editor, but ultimately this is ending up as like being run as Java code. It's just something a little bit funky with having this IDE, and you don't have to define like a main function. You basically have like a main file, which is sort of implicitly inside like your public static void main thing if it used to Java. So it takes away some of the boilerplate, but yeah, you could copy and paste this into Java and it would work just fine. And what we're doing, by the way, is trying to generate a tool like this where we can place down points and have it sort of generate and fill in stuff. Yeah, go ahead. You got Java questions. I could maybe help you out. In fact, I'm just about to take a break, so if you need some time to like write something up, then maybe if you could do that and have that ready in a few minutes when we get back from the break, and then I can probably answer that in a more sensible way. Yeah, but I'm down to go on a tangent and talk about stuff and play around with Java. That's no problem. So I kind of want to get to this milestone here, which is where... Okay. So again, to recap what we've achieved so far, we've got something where we can place down points to form like a polygon. So we're trying to draw this city. It will kind of connect these up together for us. And we can have like neighboring areas as well. And what this will do is it will say, okay, if these are neighboring city districts, I want to like start drawing some roads, and those are going to be like inset from the edges of these districts, so that it creates a space in between which kind of can form this road. And we've got that working, so we have this like road space in between here. The next step is to draw some buildings in here. So the way we're doing that is we're yet again kind of drawing like an inset shape inside here. And then all we want to do is kind of connect up sort of like this, right? And make blocks which are like deformed to fit this shape, but are more or less like evenly spaced along this area here. You know, maybe they end up looking like that. So that's kind of what we're working on just now. Okay, looking at your question. So you have an executive service. You fixed thread pool. So if you hover over that, do you get like a more detailed error? Where does executor come from? Oh, so first of all, are you missing the S on the end of executor? Is it possible that you're missing the S? I think you may be missing an S on the end. And then potentially I would check that you know, you'd have like your import statement. No, you'd have like import this. Sometimes what happens is it will, I don't know if you ever use your IDE to also automatically import stuff. It will import some random ass thing which has the same name, right? Like I'll start typing like executors dot blah blah blah, and it'll say, hey, do you want to import executors? And it will import like the wrong one if there are multiple things in different packages named executors. So make sure that you've got this specific import, and make sure that you've got an S on the end where you say executors dot new fixed thread pool. Because there is something called executor, but it doesn't have that method. What Java sometimes does is you'll have, so there is something called executor, which is this interface, and then there are like implementations of this, but then they'll throw a load of utility code into like executors, right? Like in Java, you can do like array dot some things, and then there's arrays dot, and then there's a load of utility stuff. So they tend to put utility stuff in something with like the S on the end. I would, 9 times out of 10, I think that's probably what's going on there. Let me know if that works for you. So I kind of want to create these buildings. Yeah, like normally if you get the red squigglies, then I don't know what ID you're using, but there'll be a way, like if you hover or if you look at the bottom, you'll get, okay, yeah, cannot resolve method. I'm pretty sure you're missing an S. It's a very super easy mistake to make. So we're going to start creating these buildings, and a building is, right now it's just going to be 4 points. And the points are pretty simple, right? So we've already figured out, let's say if this is like the start point of this section, and this is the end, then we've already figured out the start point of the front. Let's start front. We've already figured out the end of the front. It's here. We've already figured out the start of like the back end of these buildings, which is here. At the end of the back, and we also already figured out this step. Just like, yeah, we've got this step here, and we've got the corresponding like smaller step here. So we kind of just need to get these vertices and kind of link them up to make this building, and then just like step along by this amount, and then do the same sort of thing. Yeah, so that's what we need to do. Okay, still doesn't work. If there's another error, let me know. We'll see what we can do. I think the order I'll do these is like 0, 1, 2, 3. Yeah. So like start front. So it's going to be does the type of Java matter? Let's take a look. So this is in Java 7, so it's possible using a really old version. Yeah, probably not. Like, Yeah, I don't think so. It should. You fixed it. Cool. Using the latest. Yeah. I would expect. To be honest, I haven't used like super new all the way up to like 12 now. Or 11 or something. I would imagine this would still work. If you should be getting a different error, presumably. Maybe the import statement is missing now. I don't know. Yeah. Feel free. Send a screenshot over. I've started numbering stuff starting from 1, so let's be a proper programmer and do it with 0. What do we have here? Yeah, so you're still missing an S, right? So this is grayed out here, which means you're not referring to it in your code. And then this executor is missing an S, so it's still referring to this thing, which doesn't contain that method. Well, it should have the S. The S is definitely correct. So if you put that in, and then let me know if there's a different error, perhaps. Yeah, this will look different if you use the S, so let me know what... and this sounds like a cool project, by the way, this ant colony thing. I don't know anything about it, but... This is interesting stuff. Cool. I wonder if this is deprecated. No. Ah. Shortest distance location. Oh, so is this like, yeah. So when I was at university, I did some like biology-inspired computing stuff. Yeah, right. So it's like they lay down scent trails and things like that, and it uses a way of generating a shortest path to something. Yeah. I'm sort of familiar with that kind of thing. I don't think I've ever made this one specifically, but some things along those lines. Yeah, that's cool. I feel like I need to look in your IDE because to figure this out, because it looks like with that S it should work to me. So it's maybe to do with like the import settings for the libraries or how things are set up in IntelliJ. Yeah. So unless you get a different error with the S, I'm not sure why you would see that. Another thing you can do is hold Control and click on the word executor or executors that's here, and then it should take you to the source code, and you should then try and find that, because otherwise, I don't know, otherwise it may take you to some random version of that you don't want, but holding Control and clicking on it should take you to the definition of executors, which should then show you what's actually in there, and maybe that'll give you a hint as to what's missing. Oh, hang on. Should that P in thread pool be uppercase? Could it be that? Another thing that I pretty much always do. Another thing I pretty much always do when I'm coding is I will never type stuff out because it's so easy to make those kind of mistakes. I will start typing out p vector dot, and then I'll press Control Space to bring this up, or I'll start typing, and I will always use autocomplete because it's the only way I know that I've spelt it correctly and it's got the correct case and stuff. Hopefully that worked for you. Oh. Hey, thank you. I feel like I earned that follow, but thank you very much. Cool. Okay, now I'm almost there with this. Can I do that? Maybe not. I'm kind of rushing here. So we got this building. Cool. Now let's go through. No, you're welcome, you're welcome. It's cool. Welcome to programming, right? This is, you need insane patience, and it's always these tiny frustrating things which screw you up. Yeah. I mean, yeah, right. I mean, you're a student, you're probably focusing on like algorithms and data structures and this cool ant colony stuff, and it's these practical little things which can still like trip you up like all the time. Happens to everyone. I mean, I've been programming for like 20 years and I do this shit on the regular, so don't worry. Yeah. Cool. Okay, so I've done something kind of weird here. What's going on? See, it's kind of doing what I want and dividing these up, but I've probably got stuff like slightly mixed up, so I'm going to get rid of some of this rendering code that I don't care for. Yeah, go ahead. What's the question? Okay, so wow, this is a mess. Whoa, what's going on here? I've screwed up. Everyone screws up. Mine just looks weird. Okay. Generally speaking, I'll use IntelliJ. You know, okay, I'm going to open IntelliJ, but it may have some confidential stuff, so I'm going to quickly switch overlay for a second. I don't want to bring up like some client's work or something. Okay, almost there. It's just opening. Okay, here we go. Add some stuff here. You know what, I should have created a different kind of project. Java. Program better than when you're drunk. No. Okay, so there's a very famous thing called the Balmer curve. I don't know if you've heard of this. Balmer peak. It's kind of a joke, right? Programming skill versus blood alcohol concentration. So other people have realized this. Called the Balmer peak. It was discovered by Microsoft in the late 80s. Somehow blood alcohol concentration between this level gives you peak programming skill. Yeah, so it's a joke, but like people have thought of this. I think it's normal, right? That maybe it helps you loosen up in certain ways. I don't know. So I've had my class. The way I basically never import anything. So let's say I need an array list, right? There we go. This is how I import stuff. I start typing and autocomplete goes, oh, did you want to import something? I press Alt, Enter, and it imports it. My list equals new array list. If I use autocomplete, it's already imported it for me up there. If I hadn't have done that, and I just typed it here, then yeah, I would see this thing. So this is generally how I import stuff. So the one you had was, what was it, executors? Yeah. First up, so I kind of use this to navigate things, right? Like I started typing, then I'll press dot, and then it'll bring up all the contents of executor. So at this point I'll go, oh crap, hang on, there's nothing in here. Like what's going on, right? Like I don't know what's going on here. And then I can control click and I go, oh, I'm just in some interface with like no code in it. So then I'll kind of go back. I would maybe have realized the problem at this point, or maybe I'd be typing again. And I'll go, oh, hang on, this is what I want. And now when I press dot, and now I've got what I need in it. And if this autocomplete doesn't appear, then I know I've screwed up, right? Like it's at this point that I would realize I basically never type anything, because it's just kind of error prone. Yeah, so that's the way I kind of do this stuff. Yeah, right, I mean, IDEs are awesome, and I can control click this, and it will tell me, oh look, there's two versions of it. You probably meant one or other of these. Now I'm using this, I can control click and it will take me to this. If I'm lucky, it's got a nice comment. Yeah, IntelliJ is pretty good at this, so I would generally speaking use this like all the time. Like if I got this error, the first thing I'd do is control click here, see it's not defined, and then I'd probably search. I would maybe Google executor new thread pool, and then this one's tricky because it's, even if you Google it, you may not notice a difference, right? I think it's a common thing in human nature that when you're reading back over something you wrote, you just skip over all your errors, right? If it's English, writing an essay, it's all the same. You're just blind to your own errors. It's why even the best authors need editors. We don't have editors, I guess. You either have code review, or the best thing we have is like the IDE, like turning stuff red for you. So lean on it as much as you can, basically. Cool. This kind of stuff is more annoying to debug because I'm probably doing something super wrong here. In that I'm using these vectors are not what they should be. Yeah, I mean, it's a couple of hours in now, right? And this is kind of like geometry type stuff. Once I get past this stage, move on to the next bit, which is a bit more, or maybe be a bit more understandable. Basically, I'm trying to draw boxes here, and I've got these kind of lines, which more or less seem to be defined correctly. But at some point, some vector I've generated is pointing way off in a crazy direction. Try, fail, and try it again. I really like to do stuff in an iterative way. So again, if you watch back through this or any of the old streams, we have like all the VODs up here. I'll try and get something up and running as soon as possible and run the code as often as possible. But like the longer I write code without actually running it and testing it out, the likelihood of there being a crazy error like super increases. This reminds you of traveling salesperson, something like that. Or you mean your ant colony stuff, or this kind of thing we're doing here? Done something really strange here. Let's just do 2. Okay, so we're getting the correct like waypoints along here, but these things are totally wacko. So it's my step vector. That's cool. That's cool. So yeah, so for my university dissertation, I did something sort of similar to that, which was to do with how blood vessels form, which is kind of a cool project. So the way that worked, this is a totally irrelevant tangent, but so you've formed like a grid world. It's not going to be a big enough grid to make this work. And you had like things which needed oxygen, right? Like body cells which like need oxygen, and they would kind of send signals out saying, "Hey, give me some oxygen, please." And then you'd have blood vessels, which would kind of be, you know, running through something like this. And then what would happen is that kind of randomly these blood vessels would sprout little capillaries, which would generally move towards like things which required oxygen. So you'd start sprouting like this, and then maybe they'd like sprout again like that, and then they'd kind of rejoin, and then we'd calculate like the flow of blood through these things, and bits which never got connected would like wither off and die. So you'd end up dying here, but you've now extended the network. You know, now this can start growing out down here, and maybe it reaches this thing. So yeah, it's kind of a similar thing where you have stuff moving around these paths, and the stuff which doesn't get any traffic kind of like withers off. So it's a way to like generate optimal paths, or like in this case like a network which supplies oxygen and stuff. What we actually did was we simulated the actual flow of liquid through this, and it was to do with like the pressure and like the flow rate. So it kind of does the same thing, but it was like one level more complex because we kind of calculated like pressure and blood flow and stuff like that in a simple way, like a super simple way, like just simulating these as if they're like perfect cylinders and blood is like perfectly smooth fluid and all that stuff. But that's kind of the basic gist of what we did. Okay, this is annoying me. This is the kind of the kind of thing which is like hard to debug. So so I know it's these points which I'm getting, but it's the kind of offsets which are weird. So. Oh, hang on. I know what's happening. It's this thing which is drawing these normals which I no longer need. Like Bayesian stuff. It's been a long time. Like, yeah, okay, this is what I wanted. I think I was just drawing some extra debug noise. So, yeah, I've done a bit of like Bayesian stuff for like fuzzy matching. So I used to work in IT, and one of the big projects was like detecting whether two customers who registered with like slightly different spellings of their names and addresses are actually the same person, with like some like fuzzy matching for like fraud detection type stuff. So I've done some stuff kind of along those lines, but I'm not super great mathematically. Like, I do a lot of game stuff, so things like geometry and a bit of statistics I'm fine with, but other things, like, not always. Yeah. Okay, is this finally going to work now? Boom. Okay, this is what I've been trying to do the whole time. So, okay, so we've now got these kind of... These would be houses, I suppose. These things can connect up. There's still issues where things are... No worries, no worries. Okay, so we've hit that milestone here. I'm realizing now that having these things connect to the corner... Okay, for one, this is like not correct. Oh no, this is the leftover space. So having things... there's a couple of things. First of all, I kind of don't want this to connect to the corner. I'd actually like it to kind of connect flat, otherwise we're always going to get this weird fan spready shape of buildings. The other thing is this gap that's kind of at the end of every row. You can kind of see it here, where the number of buildings doesn't exactly fit. I kind of want this to become an alleyway, but like maybe distribute it, put it somewhere else along the row, right? So it's not always on like the corner going clockwise, because it looks kind of odd. Yeah, so those are two things we're going to do when we come back.